Hi everyone, welcome to this lecture. So this lecture is a part 2 of project 1 on KNN. So in part 1, we have already created the dataset using a function makeBlob. After creating a dataset, we visualize the dataset by performing a scatter plot. So this is the scatter plot. Here we plot the second feature against the first feature for those value of x belongs to label 0. And then we have a second scatter plot where we plot the second feature against the first feature for those value of x belongs to class 1. So we can see that for class 0 or for label is equals to 0, we plot in a red color, and the class 1 or label 1 is plotted in a blue color. Now, this is for the understanding of a function makeBlob and for the understanding that how to visualize the data. Now, in order to perform KNN classification, we need more points. So what I am going to do is to generate 1000 points here. Okay, so I am going to generate the 1000 points here. Let's run this cell to generate the 1000 point. And here I can confirm the shape. So the shape is 1000. The features are still 2 and rest all the input parameter for the make blobs are same. The only difference is that I am going to generate the 1000 sample. Okay, similarly, the shape of y is now also 1000 and I still have two labels, that is 0 and 1. Now I can visualize the data. If I visualize the data for 1000 sample, we can see that we have a data, we have 500 point in class 0 and 500 points or data points in our class 1. So now the data has been generated and has been visualized. Now it's time to apply KNN classifier, but before the application, we need to split the data into the train test split. So here I am splitting the data. I am passing my features, I am passing my label, and here the test size is 20%. That is, out of the 1000 sample which are present in our data set, I am going to use 20% of a sample as a test and 80% as a training. Here random state is equals to 42. It means every time I run this line of code, I will get the same sample in the training component, in the testing component, and also in the training labels and the testing label. Let's run this cell to split the data. And here we are going to visualize the training data. And here I am going to visualize the test data. So this visualization code is same as we used here. That is, we are going to use two scatter plot. So in the first scatter plot, we are going to plot the second column of our training data, which belongs to label 0. And then we are going to plot the second column against the first column of our training data, which belongs to label 1. So this represent the training label, which is equals to 0. And this represent the training label, which is equals to 1. Here the size of this S is equals to 30. This is the size of the samples. And first sample is in red color and second is in blue color. These are the font size. So the X label will be feature 1, feature 2, and the title of the plot is data visualization. Let's run this cell and we can see that we have a training data. So this is the training component of the data. We can see that we have the training samples belongs to class 0 and training sample belongs to class 1. So we have the plot against the feature 1 and feature 2. Okay, now we can also visualize the testing component of our data. We can see that in the testing component, we have only 20% data. So this belongs to class 0 and this belongs to class 1. So after creating and visualizing the data, we have splitted the data into training and testing component, and we have also visualized the training component and the testing component of our data. Now it's time to apply KNN classifier. For KNN classifier, I will instantiate K neighbors classifier and I will call it as KNN. Let's run this cell to instantiate our classifier. Here I am fitting my classifier to the training component. Fitting means that I am going to train my KNN classifier from the training data. And here I am getting the predictions from the testing data. Let's run this cell. So I have the prediction and here I can calculate the accuracy easily by comparing the prediction of the model with the actual labels. Let's run this cell. So we can see that the accuracy is 100%. Okay, now visualizing the data predicted by the KNN classifier. So here I am passing ypred is equals to 0. That is, those predicted labels belongs to class 0 and ypred is equals to 1, and I am passing this index to my testing component. Let's run this cell. So we can see that this is the predicted data. If we compare, this is the predicted data by the model. If we compare the predicted data with the testing component, it is exactly the same. You can see it is exactly the same. That's why our accuracy is 100%. The other reason is, if we see the testing data, there is a gap between the testing data. It means the testing components are well separated both for class 0 and class 1. That's why we are getting a very high accuracy. There is no mix-up. There is no overlapping between the samples of class 0 and class 1. They are well apart even in the testing form. That's why our model has classified them very easily. And if you see the classification, if you see the predicted samples, they are exactly the same as that of testing. That's why our accuracy is 100%. Okay, let's generate more challenging data. So for more challenging data, what I am going to do, I am going to do first is that I am going to create 3 centers. That is, centers is equals to 3, and I am also going to set the standard deviation is equals to 3.5. Let's run this cell to create more challenging data again by using a function make blobs. Let's see the shape. Now the shape is again 1000 by 2. Let's check the unique labels. Now we have 3 unique labels. That is 0, 1, and 2. So since we have 3 unique labels, now in order to visualize the data, I have to perform 3 scatter plot. That is, for those value of x belongs to y equals to 0, for those values of x belongs to y is equals to 1, and for those value of x belongs y is equals to 2. And here I am using red, blue, and green color. Why we are going to plot 3 scatter plot? Because we have 3 labels. So the data belongs to class 0 or label 0 will be of red color. Data belongs to class 1 will be of blue color, and data belongs to class 2 or label 2 will be of green color. Rest, the code is same. On X label, we are labeling feature 1. On Y label, we are labeling feature 2, and the title is data visualization. Okay, let's run this cell to visualize the more challenging data. Now, this is the more challenging data. Here we can see the overlapping of the data samples. So data belongs to different classes are overlapping each other. Okay. Now again split the data into test and train. Again, we are going to select 20% of the data from this challenging data set into the testing and remaining 80% as a training. Let's run this cell to perform the train test split. Here I am standardizing the data. And for standardizing, I am importing standard scalar from Scikit-learn.preprocessing. Here I am instantiating my standard scalar with the variable sc. Here I am fitting my standard scalar and transforming to the training component. And here I am applying my standard scalar, or I am standardize my testing component of the data. Let's run this cell to standardize both the training and the testing components of data. It's time to visualize. Here I am only visualizing the testing component of this challenging data set. Let's run this cell. Now we can see that in the testing component, again, all these clusters are not well separated. They are mixing each other. That is, the 3 classes are mixing with each other. Their data samples are not well separated. They are overlapping. So that is going to be a challenge for KNN classifier. And now we are expecting the accuracy of less than 100% because we are expecting few misclassification from KNN classifier, because this is the more challenging data set. Now applying KNN classifier, this time I am calling it KNN_2 because this is our second classifier of this project. Let's run this cell to instantiate the classifier. Here I am fitting my KNN classifier to the training component. That is, I am training my model on the training component, and then I am getting the prediction from the testing component of a data. And here I am comparing the prediction of the model with the actual label of a testing data. Let's run this cell to see the accuracy. Now we can see that our accuracy is dropped by 7.5%. Let's visualize the predicting data. So if we visualize the predicting data, we can see that model has few misclassification, especially about this point. According to model, this point belongs to this red label, although it belongs to the blue label. Similarly, we can see the classification or the misclassification here. So most of the misclassification is between this red label and between this blue label, that is the class 0 and class 1. That's why we can see that the accuracy is less than 92, less than 100%, that is, it is 92.5. So in this project, we learn how to perform KNN classification on a dataset. The first dataset we created was a very simple dataset where all the labels are well separated, and our KNN classifier perform really well, and we get the accuracy exactly equals to 100%. Then in order to check the further performance of KNN classifier, what we did is that we created the more challenging dataset where we saw the overlapping between the data samples of different classes. Then we perform KNN classification again on this challenging dataset where there was overlapping of the data samples between the classes. We saw that our KNN classifier also perform well and try to predict the samples well, but its accuracy is decreased from 100% to 92.5% because of the challenging dataset, because of the overlapping of the data samples. So I hope you understood the basic concept behind KNN. You understood the concept how KNN classify the data, why when KNN performs well, and when there is misclassification from the KNN classifier. So I hope you understood this project 1. Thanks for listening, and I will see you in the next lecture.